On the last working day of 2023, here we are recording the very last episode of season 2 of It Depends podcast, episode number 52. How appropriate to end this year by recapping the best of 2023 and help us prepare for 2024. To do that, I'm joined by my friend, a visionary, Rajesh Parikh. I will have him introduce himself in just a minute. Rajesh has this uncanny ability to spot trends before most of us do. So obviously, he and I joined hands because I want to collaborate with him and write a 2024 data and AI trends document. This document came out about a week ago. It's already caused a bit of a stir because there are quite a few revolutionary, interesting trends that we have spotted and a few things that are a tad bit controversial. So today we're going to take this time and go and discuss all of our 10 trends that you see on the screen, but we go through them one by one. So before we do that, Rajesh, welcome to this podcast.
Thanks, Sanjeev. It's been wonderful being on your podcast.
Thank you so much. Can you please give us an introduction?
Absolutely. Sanjeev, as you know, I run a company named Synapia Technologies. Synapia essentially is an end-to-end data and analytics platform company. The product is called Exceed Analytics. The product essentially has features all the way from data ingestion to activating your models in one single platform. In the last year has been pretty eventful for us. We have announced major features in terms of semantic search. We've also announced features in terms of co-pilots, and now we're pretty soon announcing the orchestration or enabling companies launch their own OSS models on top of Exceed. That's basically been the journey over the last year. We find this exciting because we've been talking about some of these for a while, and we see now that the industry is also moving in the same direction. And that's kind of very exciting for us.
Very nice. So Rajesh and I got together because we were reading all these articles, like McKinsey, for instance, has declared that AI will add trillions of dollars to the global economy every year and increase our GDP globally significantly for many countries. So it immediately raised sort of a red flag in our heads. How can AI add significant economic value when businesses need to make investments that are very targeted and they need to fix the necessary plumbing of their architecture? Not only that, we still have challenges with our data space. So how do we overcome those challenges? So we wrote the trends document as sort of a guidance because the space of AI is moving really fast, and we wanted to discuss how can the readers make the right bets. So to do that, what we did was, as you can see in this slide, we divided our trends into three parts. So I'm going to go through a little bit of definitions before we go and discuss each of these trends. So the first trend, first set of trends are under this category we call rising. Rising is a necessary plumbing, architecture, and evolution of data and AI infrastructure, along with how do you activate it? So we talk quite a bit about autonomous agents, task assistants, and you will see that most of the rising trends are predominantly AI related. Stable trends, on the other hand, they cover all the issues that pertain to data silos, duplication, data quality, this fragmentation of data and metadata layer, which is challenging us from accruing the benefits of data and analytics investment. We talk about primarily how do you simplify and unify so we can then make our data infrastructure cheaper to manage, reduce the overhead that organizations have, so they can then focus on the business problems rather than on the technology. Finally, We will look at a declining trend. We have two declining trends. And why do we call these declining? Is because, in our opinion, they are somewhat difficult in practice. Also, they lead to more fragmentation. Maybe sometimes they are a bit too idealistic in our world. So, with that, I am honored to present these trends. You can see we have 4 trends in rising. So let's go through these. The first one is what we call intelligent data platforms. Then we go into AI agents. Then we will look at how do you personalize your AI stack and govern it. With that, let's talk about intelligent data platforms. This is a new diagram. This is a second diagram in the document. Rajesh, help us walk through this document and help us understand what is an intelligent data platform.
Absolutely, Sanjeev. So, before I get started with explaining the diagram, I just want to set a bit of a context of how did we even arrive here. As all of us are pretty aware that 2023 has been all about transform architectures, large language models. At the end of the year, we also saw multimodality as we ended up seeing some announcements coming there.
And by
From this,
multimodal, you mean it's not just text and coding, it's video, sounds, images, all
absolutely.
in a single model, not multiple models.
Single model, or let's say we would probably call it a set of models being served under a single bundle. But fundamentally, we've seen a lot of announcements where which are very exciting, both from the business use case point of view, also from how do we look at the data platform itself over a period of time, right? This coupled with a bunch of activities that we have seen in the agent frameworks over the later part of the year opened up a lot more possibilities. When we started the year, we started with prompt tuning. We started with things like how do we use the public large language models and fine tune it for, let's say, a Copilot application or a conversational interface, and so on and so forth. Right. So the primary application that we went after was productivity apps, where or an experience, a user experience enhancement through a conversational interface. But with agents, we're trying to throw this whole idea into, can the models even go further and reason and take actions just like human workers do? So essentially, we have a canvas of opportunity here. The issue really is, while all of these things are in bits and pieces, there are two issues here. One is, if you want to harness this particular capability, this set of capabilities, you potentially could take your data to an AI app. The other way is you bring in the AI into your data platform. So this particular slide essentially gets you there, where you're basically saying that as an enterprise, you've done a lot of work bringing your data together into a single platform, or you're trying to do that for a variety of other use cases. Why not have the AI engines also be part of the data platform? Thereby, all the applications can benefit from this intelligence.
Which
There's
is
another to this particular architecture because it also optimizes for what I call bringing in task-specific models, or the OSS models, which are fine-tuned on the enterprise-specific data. So through an SDK interface, it gives a clean handover between the ML teams and the AI application development teams. So essentially, this architecture helps you not just work with the open models or the large language models, which are already there, but it also helps enable the task-specific models that the enterprises are building be available across the board, the applications or use cases they're planning. So that's really what an intelligent data platform is. In definition, it essentially infuses the intelligence layer right within the data platform itself.
So instead of having 2 separate stacks, one for structured data, which is aimed mainly for BI and dashboards, and then a separate one for unstructured data, we basically are bringing them together into a single stack.
Absolutely. And the reasoning, and there's a strong reasoning for it, because As we get into 2024, the big priorities that the enterprises need to address is, and not be left behind, is how do we get behind taking the advantage of the Gen AI opportunities that we have and convert them to use cases, right? And therefore, the proportion of use cases which are more AI-ish than BI-ish are likely to grow over the year as we get into the next year. And therefore, the data platforms have the opportunity to cater to those use cases going beyond the typical use cases they were going after, which is the BI and the analytics.
That is right. One reason why I like this diagram a lot is because somehow we managed to collapse a lot of things that we'll be talking about today into this one diagram. So,
Yeah.
for example, we've got infrastructure as a service at the bottom, which is basically this cross-cloud, because we're bringing AI to data, and your data is spread across on-premises in different clouds. So there's that cross-cloud piece at the very bottom. Can you see when I move my cursor?
Yeah,
You
yeah,
can
I
see?
do.
Okay. So then on top, we've got this concept of unified storage under unified data plane. So we will talk about it. The blue boxes, some of them have to do with agents, which will be the next topic. So we'll hold off on that. And then we'll be talking about vector databases, the RAG pipelines, and all of that. And then we've got through this API interface, we've got the front end of the agents, like the co-pilots, the data products, which is yet another topic. And then, of course, we need this convergence of metadata. So what I find really interesting is that although this intelligent data platform may look like that it's a very mechanical thing, we are bringing these two things together, it is actually very challenging because there are two types of people in this world, data people and AI. Data people are deterministic. If you run a SQL, you will get a result which is pretty much guaranteed to be correct. Of course, if your data is correct, and it'll always return the same value if your data hasn't changed. The AI people have lived in the world of probability and statistics, non-deterministic. So now we are trying to converge these two together, and that is not that as easy as it seems, right, Rajesh?
Absolutely. And in addition to that, we are collapsing or let's say optimizing. I mean, over years, if you look at the data architectures, they've been optimized for scale, they've been optimized for a certain purpose. Let's say BI is the purpose or the primary use case. But as we get into the future, we are optimizing for architecture, collapsing a variety of different opportunities. For example, we're collapsing here or unifying here a variety of data types or formats, right? That's one unification that you see here. The other unification you see in this particular diagram here is in the multi-engine orchestrator. We're basically saying that the platform needs to be able to work with a variety of different engines, right? Or need to be able to provide
So can
orchestration.
you let's get some specifically what engines are we talking about? So
We're talking about a bunch of AI engines here. For example, when you look at the models here, there are two blocks here. One is the foundation models, which are probably off the shelf versus large models, or let's say the public API based models that are already available. Then we have the task specific orchestrations, which essentially would mean the models which the enterprise itself has fine tuned, could be a bunch of them. And then you're serving these models or inference interfaces to a variety of applications through this SDK layer. Now, this is basically bringing in all the probabilistic thing that you just talked about, adding conversational interface to the applications that we have here, or building a complete agent application potentially, right? All of this are going to need to talk to the LLM inference engine and potentially a lot of different LLM inference engines, depending on the task that they're expected to do. So that's one kind of an orchestrator that you have, where the ability to basically orchestrate a variety of engines or the LLMs is extremely important. While we do that, a lot of applications also need to work with, let's say, the vector indexing and search and all of that, because At the end of the day, the data needs to, before it goes to LLMs, they typically get filtered in a typical RAG application. And therefore, you also need vector indexing and search capability as an orchestrator in this particular product or the application stack that you're trying to build.
So
The other engines here, of course, point to the legacy engines like for example, it could be a DuckDB, it could be a Spark engine, or various other OLAP engines that we have here, right? So in a way, this layer is simplifying because at the end of the day, what we see is that the task plates, as we call it task plates, the applications would need to work with a variety of these tasks and bring them together, right? So they could be working with, let's say, the semantic search and providing conversational interface, and also along with that, performing a SQL query. Now, all of that could happen in a single application, and the application could become fairly complex if it has to deal with a variety of different interfaces to get through this particular requirement. So what we're really doing here is, or an intelligent data platform is poised to do, is make sure that these interfaces, irrespective of what those models or engines are, is seamlessly available to all the applications through a very consistent interface.
that is great. So Rajesh, we have introduced a lot of topics in this talk. So let's go through them one by one, because I'm sure like people are asking, thinking at this point, what the heck is a Semantic Router / MOE? So let's go to the agents, and then we will go into the task-specific models you talked about, and then we'll go into vector searches. And so that's a story that we are going to now embark upon. So here come the AI agents with some numbers to help guide through this. Walk us through, and what is Semantic Router MOE and what's going on in this diagram?
Well, in a very layman's term, essentially what's going on here is just like we have a services architecture in a typical software architecture, where you would have a bunch of services endpoints, and there may be a gateway in front through which these URLs get routed to different services. The semantic router, or MOE, essentially is nothing but, it's a model which is routing based on what kind of a task or a question that the user is asking. So depending on the question that you have, a particular task-specific model or a foundation model may be called in this particular diagram. So that's really what a semantic router would mean. The reason we call it semantic is because it's based on the English rather than the URL in this particular case. Right. So in a most simplistic form, that's really what that particular layer means, or the block means.
So
right.
What is MOE?
I'm sorry, I think I missed the.
So if I may, so MOE, if I may, is a mixture of experts. This is a new technique. Where we are basically, correct me if I'm wrong, because we are all learning this. This is something that just got sprung upon me. So mixture of experts is
but it's again a multiplexer where you're choosing an expert for given instruction or a prompt that the user is pointing to.
Like, for example, can you give some examples?
So for example, let's say if let's say I'm trying to do a text to SQL as one of the tasks, then I might actually pick a task-specific model which has been fairly well fine-tuned for SQL. Or let's say I'm trying to do a code, write a code, or let's say troubleshoot a code, then I might pick a code model under the hood, which has specifically been built or tuned for, let's say, code like Python, right? So we have a variety of specialized models under the hood. We call it task-specific models. And the MOE as a layer is basically trying to dissect or route these task to specific models, inference endpoints under the hood.
I see. So, for example, there is a very well-known company that came into existence, I think this year in Paris, France, called Mistol. And Mistol made news because they got $124 million seed investment, which is massive investment. So their newest model came out last week called Mixtral. which is an MOE. So it's 8x7b. I think there are eight smaller models that are chained together. So
Yeah.
so I just noticed in this, like I was trying to walk through this. I know we added numbers in our document, but we're missing number two here, by the way,
Yeah.
you know. Uh,
Let let me walk through this, but fundamentally, let's look at what is an agent at a high level. An agent at a high level essentially is going beyond a copilot scenario, which is more like extracting information and supporting the user to basically get the information and then perform the task. In a typical agent case, it may further break down the task into a set of subtasks, uh, and then reason out each of these subtasks and potentially interface with the external environment to get the information that it needs to perform the task. So you actually see there are three or four different pieces in this free flow diagram. One is, of course, the user triggering the task here. And then you have this LLM stack in the middle. So when the user triggers a task, uh, the LLM in the middle basically uses that to break the task down into multiple tasks in a typical thought and think process, and creates a bunch of subprompts or subtasks. Each of these prompts are then further fed back to the LLM to further hash out what is the next set of action. Now, the action could be extracting information or maybe searching the internet to get the specific information that you want. But essentially, you trigger the action, you get the information back here, and then basically assimilate the information that you've got to perform the final action that the task is expected to give. Right. So the subtask could be a variety of tasks. This could be writing code. It could be potentially searching for information on internet. It could be extracting information from a document. All of this basically comes together, and essentially the user gets the final output in the form of a completed task. So a completed complex task essentially.
So basically, you could call a model and say, go do some filtering of data, like vector search. Then you could, the agent, the task could say the next one needs to do ETL, so call an LLM, a foundation model for that. The next one could say, build me a dashboard, or do maybe address
Absolutely.
completion task. So basically, the AI agent is bringing together all the subtasks that are required. And if I'm not mistaken, this architecture, there's a name for that, and it's called React. This is a different
Absolutely. Yeah.
React from the Facebook React, which is front end. This is RE for reason and ACT for action.
Absolutely. Yeah.
So that is RE, ACT is an architecture.
Only one kind of an architecture or a framework for how you build agents, but there could be other forms of frameworks in how you build agent. But fundamentally, you are adding further to what you were doing with the typical agents in 2023, which is basically building an RAG pipeline, or you were potentially just trying to build a conversational interfaces or copilots. Here, what you're basically saying is, can I go beyond those, add the reasoning as well as actions so that I can perform even more complex tasks more autonomously? That's really what you're trying to achieve with AI agents.
Okay. So that's great. I have a quick question. So you mentioned RAG, which is retrieval augmented generation. We'll talk a little bit about it when we go to vector databases. But but RAG pipelines have been very popular this year.
Yeah.
Are you saying AI agents can uh, avoid, or is the next generation over RAG pipelines?
I'm not essentially saying that, but what so if you think about a RAG pipeline, they look very similar to the typical data pipelines that we build today, which is there is a human which is stitching up this pipeline. First, it goes the instruction is first filtered down through a vector search, and then the prompt is built, and then that prompt essentially goes to the LLM, and the response of the LLM may further feed a downstream process. And that's how we're doing. But the basic idea about the RAG pipeline is where the task has been very well thought about. It's a simple task, and the set of steps have been hardwired in a way by the engineer who has actually built that RAG pipeline. Versus in this case, you're giving a broad guidance to the LLM to perform a fairly complex task, which means that, and then you've given a set of tools to this particular agent through which it can actually extract or which are important for him to perform the task. Let's say you're doing a data analysis task. I'm just taking an example. Now, this data analyst task could require the LLM to further break down this into multiple different small tasks and then execute each of these tasks before it finally synthesizes an answer, which typically today is done by a human analyst. So there is an element of reasoning involved. There is an element of playing around with a variety of tools and data exploration. All of that is involved before you actually come to the conclusion. Now, these are the kind of tasks which you cannot typically do with a RAG pipeline because you're not very clear. The task is fairly complex and it's not very well defined at the point when you're actually talking about it.
That is great. All right, so this is great information. We think AI agents are going to be a very big trend in 2024. So you'll be hearing a lot more about AI agents, which takes us to the next trend, which we call personalizing the AI stack. And in that, we actually have three sub-trends. We're talking about how do you create a task-specific or domain-specific model. That's going to be a very, very big trend next year. And also high-quality data sets, because the biggest moat you have is your data. So we'll talk about this in quite some detail. And then finally, we've already started talking about the growth of vector search enabled databases. So we'll talk a little bit more about that. So let's talk about fine tuning. Again, back to you, Rajesh. How do you create domain task specific models?
Absolutely. So before I get started on this, I basically want to tie it to why did we talk about agents and why are we suddenly talking about plumbing here? And fundamentally, the issue that we have seen over 2023 is we got started with these large language models. We performed a bunch of experiments with those models. Some of the results were exciting and some of them were challenging. The biggest thing that we learned is that, hey, the prompt tuning actually becomes quite a bit of a challenge the time you want to move from prototyping to production. And fundamentally, you often do not get the desired accuracy for a variety of tasks because the public models that you have has probably not seen the data that the enterprise has, right? So when we actually looked at the previous slide, we talked about, hey, agents are important because the economics of AI or the value of AI will not be materialized if to the level that we want it to, if we do an incremental shift to building, let's say, co-pilots, which are great productivity enhancers, but still don't take you all the way, right? So given the promise of agents, the one of the issues that you have is how do you really get control over the kind of output that you expect and the accuracy that you expect these agents would be able to perform at, right? And that's really where the task-specific models that we saw in the unified stack comes into play. Now, these task-specific models are really the models which may be there in the OSS or may have to be built by fine-tuning OSS model with the enterprise data or the data sets which are very domain specific in this particular case, right? So this particular diagram essentially talks about the fine-tuning infrastructure. We do believe that the enterprises will not get the desired results with their data until they actually start owning this piece, which is not just, of course, use open source LLMs or OpenAI and the large LLMs for the use cases where they make sense, but also mix it up with the use cases where the domain specific data, the enterprise data becomes extremely super critical to get the desired results, right? So this diagram essentially talks about a certain flow for how the fine-tuning works today. I mean, depending on what you're doing, you could potentially have the 2 or 3 steps, or maybe go all the way, depending on the complexity of the model. But as you see here, on the top, blue boxes are essentially all the data boxes, and the pink boxes are the real flow, or the flow of how the process flows when you're building a model, picking an OSS model, fine-tuning it to build a task-specific model. So we start with the base model here in this case, and we essentially take the prompt response data set pair. This could be the task-specific data set that you've created. You feed that along with the base LLM to the transformer architecture pipeline, thereby creating an instruction-tuned LLM, right? Most of the prompt response pairs really follow the instruction tuning paradigm today, and that gives you an instruction-tuned LLM at the step 3 that you're seeing here. As you move on further, there may be a need to further tune this model for making sure that its output is controlled and governed for a variety of different parameters like safety or biases and all of that, which is very important from a regulatory or industry standpoint. So the RLHF stage is fundamentally about rewarding or penalizing a given output based on the human labeled prompts and responses that you see on top. So at the end of this stage, you actually get an RLHF tuned LLM, which becomes a candidate model for you, or let's say the ML test team to evaluate. There could be a variety of evaluation methods that used depending on what one is trying to do, and that gets you the final results at the end of the stage. Now, at this stage, either the model is acceptable, and therefore you get it to the final model and push it to the model catalog. This could be a public catalog like a Hugging Face or an enterprise model catalog. Or if it still doesn't fit, or does not meet the benchmark, you go back to the first stage, enrich the data further, and then kickstart the fine-tuning process again. So that's really the flow of how one fine-tunes the models. The real challenge today is not the fact that we don't have these libraries or frameworks which can actually do this for us. The real challenge has been, how do we seamlessly tie all this together and put it together and save time with every iteration of tuning. That is one. And the second big challenge here really is the data sets. It's still manual, laborious. Sometimes there's a lack of industry-specific or task-specific data sets available readily in the OSS. So that's really where the time investment is today when one thinks about fine-tuning a model.
Yeah, we'll talk. Actually, the next topic is we are going to talk quite a bit about data and what kind of data is used to fine-tune. But if I may add to what you just said, so a base LLM could be something like an open source Llama 2 from Facebook, for example. So you take that, and then there on Hugging Face, there are a lot of data sets that are available, or you can use your own data set. Like if you are, let's say, an insurance provider or healthcare provider, and you have your own data, then you can take that data set and train a base model. So basically, a base model is a pre-trained model. You don't want to start from scratch because it takes millions of dollars to base train a trillion token model. So you don't want to teach that pre-trained model how to understand English and predict the next word. All that you take as your base, then you add your specific domain data, like your insurance data. And in step number 2, then you need to have another data set that's asking questions and getting responses that you expect, right? So there are 2 different data sets.
Yeah, at every stage, there is a data set which is very specific to that stage of the pipeline. and and important for also making sure that eventually the evaluation that you're coming up with is independent of what you've actually seen in the training phase. So we're basically trying to create diversity here for each of the stage. And by the way, this is beyond the fact that this is LLM. This is also the classical ML
Correct.
pipeline.
Training set,
Yeah.
yeah, yeah, you see if the model is fitting properly, it's not overfitting or underfitting. So what we did in ML, now we're doing it here with so RLHF that you've talked about, I think most people know by now is reinforcement learning with human feedback to further fine tune it. So I like the fact that when we create the final model, it goes to model catalog, because when we talk about AI governance, we're going to pick it up once again. So this journey has not finished. This is only the beginning of the journey. So we've already looked at how do you create task-specific models. Now the next question is, it depends upon the what kind of data do you have. So the size of the model depends on that. We see 7 billion, 13 billion, 70 billion. So and then my favorite topic du jour is copyright protection, indemnification of models by the end user so they don't get into trouble if there's a copyright infringement. Why I say this is my favorite topic is because literally a few days ago, the New York Times has sued OpenAI because it turns out that OpenAI, when they trained GPT-3 or 3.5 or 4, they use a vast amount of data sets. What data sets they used is not disclosed, but one of them is a data set which is on Hugging Face, but it's now defunct. It's called Books 3. In Books 3, there are text versions of books and articles. Actually, Books 3 is a case that Sarah Silverman has sued OpenAI. New York Times is saying that their data set was scraped and model was trained on, so it's a copyright infringement, data quality, and then you got synthetic data. So a lot of topics. Rajesh, what are your thoughts on this? You're on mute. Rajesh, you are on mute.
I'm sorry. I was about to say that this is such a well-timed post that we did. In fact, when we wrote about it, we felt strongly about it, and it actually appeared in our post. And then just a couple of days back, we have this news on OpenAI and the NYT. So clearly, this was a topic which was which was an undercurrent for a while. It just needed a news to blow out, and people to realize that this cannot go on and on forever, and the data sets that we pick have to be copyright free, or some form of indemnification has to be available. Otherwise, we're going to shoot the AI story much earlier than we wanted to. Right now, given the economic benefits of AI, and one reason why this finds place in our document as a rising trend is the economic benefits of AI far outweigh the challenges we have with the copyright free data and all of that, right? Data sets continue to be a challenge, and it needs to be solved. And therefore, we've come up with this trend where we say that there are a variety of ways in which 2024 we are going to go look at how do we solve the paucity of data, the availability of right quality data as we get into 2024, right? So we've talked about a few opportunities which is beyond the enterprise itself are trying to solve it, which is about ecosystem play. How can a data ecosystem actually provide industry specific data sets, for example, right? Or let's say, are there a set of common tasks, let's say the sales optimization, supply chain optimization? Can there be data sets available in the OSS or even commercially, which are specifically built for a particular task? Now, there's a good economic potential here for new players to emerge and look at the long tail of data sets that the companies would actually want to train or fine tune that the LLM on. And hence, this is a big opportunity in 2024 by itself.
Yep. And the funny thing is, I saw a bunch of articles that talk about how we may even run out of data, unique data to train these models, because if everybody's training on the same set of data, so it's a big topic, but I just want to quickly mention the rise of synthetic data, which is basically
Yeah.
data that mimics real life data. And so the quality of synthetic data becomes really important. It has to be statistically similar to what you are trying to copy. One of my favorite examples is if you want to build a model to detect, predict any anomalies, fraud detection, and topics like that, you hopefully don't have so much fraud going on that you have every permutation combination. That would be a huge problem if you have so much fraud in your business, and you don't. So you create synthetic data. So we are seeing that this is a very important topic.
Absolutely, absolutely. I mean, I strongly believe that in 2024, if we really need to move ahead with AI, we need to address this particular vertical.
Yeah,
Uh,
yeah. And then the final point here, and we're not going to belabor this because we have a lot of material to cover, is that every database vendor of any fame has now added vector ability to store vector embeddings. So you can then do vector searches on your data, which uses similarity search as opposed to keyword. So that's become really big. And by that, you filter what you are going to send to an LLM. Because when you send data to an LLM, you are calling an API. So there's a cost involved of using the API. There is latency of that. And then LLMs, we know, will hallucinate. So the more refined your similarity search is, we can then have an opportunity to reduce the level of hallucination.
Absolutely. Beyond that, there's also a race condition issue. For instance, when you're playing with structured and data and then trying to index it into a different vector database, uh, usually whenever you have multiple independent entities, they can often go out of sync and you end up in a race condition. So integrated vector database also makes sense from that point of view,
Mhm.
to reduce the overall cost optimize for these kind of failures that could potentially happen.
Perfect segue to the very last rising trend, AI governance. We talked about hallucinations and accuracy. Rajesh just mentioned cost, governing the cost of that. We looked at model catalog. When you fine tune, you store it in model catalog. Once you store it in model catalog, now organizations need to know what models exist and how do they map to my use cases. So what you are looking at is an AI governance framework that we put together. I have a strong feeling that before the year ends 2024, I would have tweaked this quite a bit as we learn more. So, Rajesh, one of the thoughts that just crossed my mind as I was listening to you talk about AI agents is that I don't have a connection to, is there anything specific we need to do with AI agents, and how does that flow into this AI governance?
Absolutely. So let me crystallize and connect the two. See, fundamentally, if you go back at what we did is we optimized for architecture from day zero when we talked about unified intelligence platform.
Mhm.
Then we brought in the fine tuning as one of the uh, elements how you can improve the accuracy of a model
Hmm.
for a specific task. And as we were doing that, you have to realize that while you've done all of that without ensuring proper governance and control from day one,
Mhm.
these are probabilistic models. They will take no time to degrade as you go. So continuous monitoring is extremely important to make sure that you're actually getting the results that you're built for. These models for or the model the the applications that you build for. So, and like with the typical applications and data, we've often seen that the monitoring often becomes the runtime phase of understanding what is the real experience at the end of all of it that one is getting, right?
Yeah.
So agents are complex applications. They trigger LLM calls multiple times to get the job done.
Mhm.
And without understanding, and let's assume that the outcome of the agent is wrong, and you really need to trace it down to understand really what happened when the agent triggered a bunch of these tools or made bunch of invocations to LLMs, and without being able to understand what's happening under the hood, you're not going to be able to troubleshoot and understand the causes of failures or the causes where the agent got it totally wrong. So you also need to understand from a framework point of view. We also talk about the consumption. Is the user, for instance, even going beyond the agent, is the user actually giving the prompts that is relevant to the work that he is supposed to be using these LLMs for? So
Yeah.
there's another form of a governance here where you're also monitoring the prompts beyond the consumption, right?
Yeah.
So who is consuming, for what is he consuming? A lot of these metadata is super important when you're taking these models to the next stage of fine tuning.
Yeah.
Without
Yeah.
the understanding of what is really happening, you're not going to be able to trigger the next fine tuning phase for
So
these
the
models.
thing is, lineage is really important here, especially with AI agents. What is that lineage? And then the underlying important thing here is understanding what, like, is there any sensitive data that was used to train the model,
Absolutely.
or is there any sensitive data that is being sent as a response? So there are two aspects. There's a training aspect, and then there's an inference aspect. And AI governance has to span both. We already are seeing a very large number of compliances that are starting to come out. The
Absolutely.
EU AI Act is now out. We have an executive order in the US, and of course there's this AI Alliance, and there are all kinds of compliance regulatory pieces that are coming along. But we're going to stop here because we want to leave enough time to talk about stable and declining trends. So we've got
Yeah.
4 of these. I'm going to go straight into the first 2, unified data plane and cross cloud. So Rajesh, again, back to you, if you can help us walk through this.
Yeah. So I think we've had a wonderful journey talking about AI, but as we actually start talking about data, you start sort of getting back and thinking about, hey, what's the real state of data in enterprise with a decade of investment? And you actually it turns out that you have a variety of organizations, but broadly you can put them in 3 categories. One is the guys who have invested heavily into a platform and have been able to successfully show a story where they have all the data, metadata, as well as the data quality issues addressed. Data is no longer siloed, not fragmented, all of that. Now, this is clearly a winner organization which has thought through the architecture, optimized for the architecture rightly. But then there are bulk of the organizations don't fall in this particular category. We have organizations where data is siloed in bunch of databases all over the place, or maybe the stack is too fragmented for metadata to come together, which is really required for making sure that you actually feed in the right information for the LLMs to get you the right responses, right? So the metadata is all over the place, if not the data, because the stack is fragmented, and then you have a variety of issues with the data quality, which pretty much 80% of the organizations haven't got their act together on. So what we're really talking about when we talk about stable trends is we're going back to data and saying that if you do not address the data silo issues, the fragmentation, either in the tool change or the metadata or the data itself, right? Or the data duplication that you have all over the place, or the data quality, these are the pillars on which the AI stands, you're not necessarily going to benefit from the rising trends. And that's really what this plane is about. So as we talk about this plane, we are also addressing one more requirement for AI, which is really that we expect people to build multimodal applications. So while you unify the data in a common data lake, we are also talking about unifying a variety of data formats. This could be unstructured, semi-structured, structured. It could be audio, video, structured data, and images. So far, enterprises have primarily or largely unified the structured data. But with this particular slide, we're saying that, hey, if you really want to get those multimodal applications and the agents, you would also need to look at the other kinds of modalities and bring them all together in under the same governed layer. This helps do two things. One, of course, give you the ability to simplify the governance plane as a whole. Secondly, unify the metadata that is very crucial for building these applications. And third, it enables applications which really are the AI applications, the AI agents and the co-pilots and all of that.
That is great. And I think one of the things that also matters here is this unification of formats. We have seen the increasing focus on things like Apache Iceberg, Delta, and then Hoodie. In fact, Hoodie from one house has now this concept called one table, which is further abstracting. You could use Iceberg or Delta or Hoodie, and they have a common format, or they do that translation across different formats. Databricks also announced something called Uniform to do exactly that. So we see that unification is.
So that unification is still on the structured data formats. But in this slide, we're additionally talking about bringing the other modalities, essentially.
Correct. Yeah. And then cross cloud, because we know that data is across different cloud providers or on premises, or actually more and more even on the edge. Just in last few weeks, we have seen Google launch Gemini, their new multimodal foundation model, and there is a piece that can now run on the edge. We haven't talked too much about the hardware side, and so we're going to avoid that. But there's also a lot of movements in between NVIDIA. We have new hardware coming out from Intel, from AMD, new ARM devices. In fact, we'll have new Microsoft Surface Pros. We'll have new MacBooks. Everything will be with chips that are optimized for either training or inference, and software stacked with AI infused in it.
Yeah, and I think one of the other benefits of cross cloud here is really optimizing the economics of LLM and the inference servers or the GPUs that one is trying to use, because each of these GPUs have could potentially have a huge pricing optimization benefits depending on the use case that one is planning for, right? So the cross cloud is also about leveraging the resources which are best fit for a certain use case that one is working on.
Very nice. All right. So now in order to do that, it turns out that just like we've got data silos, we don't want to get into a fragmentation of metadata. A lot of metadata that we collect on our underlying data assets and now on the AI assets, we need to have it be unified so different personas can leverage the same metadata. Today, what happens is we've got so many different products. We've got data catalogs, we've got data preparation, we've got data security, data access governance. All of these are having to do their own discovery of metadata because we don't have a common metadata standard. We've tried it, open metadata, open lineage. There have been a few attempts, but they haven't really succeeded. So this becomes a big challenge when you've got separate products that do separate data governance pieces, but they don't have the same understanding. So And this is the reason why we see how and why data observability has come up, because data observability is trying to provide this single pane of glass where you have this visibility into the quality of your data, the health of your pipeline, and even the usage and the cost that is associated with usage, this concept of FinOps. So these are the trends that we see will be stable and continue. Rajesh?
Absolutely. I mean, this is one of the hardest to achieve given how the tools have come up over years. I mean, what we're really saying is it's going to become super critical when you start planning your AI use cases. And the more they are together, the better. Whether you can get an ideal unified meta plane would depend on the choices that organizations make. But then largely, each of these layers, for example, we did come across very recently that for a text to SQL kind of a use case, you really need the semantic layer and the knowledge graph piece of it become extremely important for you to really get the accuracy that you really are wanting to, right? So the ability to get a lot of these data together, metadata together, is going to be very crucial when you start talking about accuracy
Yeah.
with the use cases that these RAG pipelines are really working on.
Yeah. Yeah. I think data.world has done some benchmarks that show how the accuracy of LLMs go up if they use a semantic layer knowledge graph.
In fact,
So
we have also seen in our labs that the more the metadata, the better the outcome of that particular use cases.
very nice. Great. So finally, we want to talk about data product. Data product is actually a topic that I covered quite a bit in 2023, published a book called Data Product for Dummies. The main takeaways of data products is that we are applying a product management philosophy to building our data artifacts, not just data artifacts, even AI artifacts, even a pipeline could
Yeah.
be a data product. An AI agent could also be a data product. But the idea is that we're thinking through the entire life cycle. There's not a project that you do it and then you move on and disband the team. You treat it as a product with its own life cycle, and you focus not just on functional requirement, but on non-functional requirements. What is the performance? What is the SLA? What quality are we saying this is going to deliver? How do you discover it? What is the ROI? Because once you have a data product, it is very easy to ascribe a value. What did it cost me to build this data product? What does it cost me to maintain it? And also calculate the value. The most important thing of a data product is to delight our data consumers. So user experience becomes really important. Now, data products actually have been around for a long time. We are now calling it a data product, but it came out of data mesh. It was one of the principles. Data as a product is one of the four principles of data mesh. And that takes us to the last section of declining trends, because we got two declining trends. And Rajesh, take us home.
So I think even before we put it, I think I mean, obviously there are two trends we are talking about here, which is one is modern data stack and the second is data mesh.
Mhm.
The modern data stack has generally been a declining trend, and there is a consensus there. One of the big reason has been what we've spoken about, which is really the transition to unification because of the complexity of the fragmented ecosystem itself. What has happened is we went through this journey where we said we need best of breed applications, point applications, micro applications. And what really that did is you got into 10 to 12 different tools which had to come together to build this data platform that the enterprises need. Now, as the players within this ecosystem started expanding their own footprints beyond their original core, you got into the interoperability problem, you got into data duplication. So at the end of the day, enterprises had all the tools which needed massive amount of integration, and yet you had the quality issues, the race conditions, the duplications of metadata data all over the place, right? So the all the best of the breed tools, while they did well with their own individual feature, together they did not come together as an architecture which is optimized for what the enterprises need. And this obviously is the bigger kicker as to why we are talking about a unification across the board in all the slides that we have gone through so far, right? Unification is important because it values or it optimizes for architecture versus optimizing for a feature or a specific feature that one is working on. So that's really the reason why modern data sec is not is or let's put it this way, is a lower priority if one is optimizing for architecture. The second obviously is data mesh, and database essentially is a lot of concepts under the hood. One of the key concept of data mesh is decentralization. Beyond that, there is data as a product, policy as code, and a bunch of others, and they're all good concepts. And it's very hard to find fault when you look at the time this particular architecture was made, which is in the context a couple of years back, where the data teams which were centralized were not necessarily generating the business value that the businesses wanted to see or the functions wanted to see, right? So one of the articulation was, why not let the functions handle the data, because they know the data better than the centralized data team, right? But what has changed with Gen AI and AI in general is that the economic value that we are foreseeing that the enterprises should actually go grab when they enter 2024 is really about accelerating the AI development and accelerating the AI products. And AI would need a lot more skills than what the data or let's say the BI or the analytics that the functions could have managed pretty well beyond if we didn't have a Gen AI trend. But AI would need centralization for accelerating in the initial phase. And that's really the reason why we believe that in the context of architectures, you may still be better off pursuing a unified intelligent data platform, which is largely centralized and helps you accelerate the AI applications and the productivity goals that you have because of that.
Yep. That is really good. And I do have to say that, this is probably the most controversial two trends that we have. Rest are sort of expected. This came as a bit of a surprise. There's been a lot of chatter on LinkedIn and on X, where some people are saying that data mesh has not really done a very good job of showcasing very successful implementations, and now we're going to see more of that. So no question about the principles, the great principles. It's just that we think that simplification and unification are more important, especially with AI now converging with data. But I just want to acknowledge all the good work that has gone into this and some successes that these two have seen. So
Absolutely. And by the way, we have taken the data products, which is obviously part of data mesh, as a trend that would continue, and we believe it's important for even AI to succeed. And therefore, it's an independent trend in our slide deck.
So with that, we've come to the end, and thank you everyone for watching this episode till the very end and for your support of It Depends podcast series. We will see you in season 3. But thank you again, and Rajesh, it's such a pleasure talking to you.
Thanks, Sanjeev. Thanks, everybody, and wish you all a happy 2024.
Thank you.